Okay, let's look at example 18.5, altimeter. An altimeter. This is a device that measures the altitude above sea level. Okay, that's what this device is. And the application of this example is inside an airplane cabin. Okay, and inside, if you've ever been inside one, well, I don't think you'd notice it, okay, but inside an airplane cabin, because airplanes can fly at, their cruising altitude is around 10,000 meters. And we saw that at about 10,000 meters, the pressure of the air is about a quarter of what the pressure is at sea level. And this can cause altitude sickness. Okay, so what they do is they increase the pressure inside the cabin so that we are not experiencing the pressure that you would at 10,000 meters. Okay? So you're wearing this watch, okay, your altimeter watch, and inside the cabin, even though you're flying at 10,000 meters, your watch is saying you're flying at, your altitude is 2,500 meters. So what your watch is basically saying is that the pressure inside the cabin is such that it's the same as if you were at 2,500 meters above sea level. So there's a higher pressure inside the cabin. Okay, now what is the actual question of this example is that you want to determine what the magnitude of the force is that is exerted by the air on the airplane fuselage. Okay, what is the fuselage? Okay, if you look at this airplane, that is the fuselage. It's this kind of cylindrical section of the airplane. Okay, that's the fuselage. Okay, so we want to know, we've got air pressure outside, okay, and that's the air pressure at 10,000 meters. And we've got air pressure inside that's pushing out. Okay, does it make sense? And so we want to know what is the force that is being applied to this fuselage. What's the force? We've got the outside pressure and we've got the inside pressure. Okay? So, how are we going to do this? Well, we know, first of all, we know that force, we know that pressure is force over area. So the force on the fuselage will then be pressure times some area, multiplied by some area. And this total area will be the total area of the fuselage, okay, the surface area. And this pressure is going to be the difference between the pressure outside, or let's put it pressure inside minus the pressure outside. Now we know that the pressure inside will be larger than the pressure outside. Okay? So what is the pressure on the inside? What is the pressure on the inside? Well, the pressure on the inside is the pressure at 2,500 meters. Okay? So if you go to this graph over here, let's just erase this. And you go to 2,500 meters. The pressure, let's just make 100% sure to see what they say here. So the pressure at 2,500 meters or 2.5 kilometers is 80 kilopascal. And the pressure at 10 kilometers is 24 kilopascal. So much lower pressure at 10,000 than at 2,500 meters. So we calculate that difference between the pressure on the inside of the fuselage and the pressure on the outside, and we get 56 kilopascal. So there's a 56 kilopascal net pressure pushing the fuselage out. Okay? So we've got the pressure now, but we're looking for the force that is exerted on the fuselage, and so we need to multiply this pressure by the total surface area. And so the way that we can do that is we can make an assumption and say The fuselage is basically a cylinder with two two half circular ends, right? Does it make sense? Okay. So what would be the area of this? This is the diameter here is, so phi is 6 meters. That's the diameter. The length is 60 meters. Okay. And so just make sure that you understand this. We're calculating the total area, 2 pi RL. Okay. So that's 2 pi times the radius times the length, plus then 2 pi r squared, which I see actually what they did here was pi r squared. They just assumed that these are flat ends here. Okay, these are flat ends. So it's the surface area of the cylinder plus 2 flat ends, 2 pi r squared. Okay, I hope that's clear. Make sure that you get this. The point is, we take this pressure and we multiply it by the total surface area of the fuselage, and we get 6.7 times 10 to the 7 Newton. Okay, that is acting on the fuselage, which is humongous, but the fuselage does not rupture because it is distributed over a very large area. Okay, so again, the idea is you can have a force, but if it's distributed over a very large area, then the pressure is low. Okay? Okay, alright, I think that's good enough.